Welcome to Learning with Philemon. In this video, we will be looking at metallic bonding and some properties of metals. In previous videos, we looked at covalent bonding, how non-metal atoms bond with each other, and ionic bonding, how metal atoms bond with non-metal atoms. Metallic bonding only involves metal atoms. Let's take a sample of pure lithium as an example. Metals tend to lose electrons to form cations, positive ions. Lithium is in group 1 of the periodic table, so loses one electron to form a lithium 1 plus cation. The lithium cations, represented by the larger circles, arrange themselves in a lattice. Note that the structure is similar to an ionic lattice, but in this case only cations are present, not anions. In this two-dimensional diagram, only one face of the three-dimensional structure is depicted. You can think of the lattice as a cube of cations, much like a Rubik's cube, where each small cube is a cation. The electrons lost by each lithium atom do not have a fixed position, but can move freely within the structure. The electrons are described as delocalized. They have no particular location, but are shared between the ions in the lattice. The structure of metals is often described as a lattice of cations in a sea of delocalized electrons. There is a strong electrostatic attraction between the cations and the electrons, represented in the diagram with the two arrows. As a result, it takes a lot of energy to separate the cations. Therefore, metals have high melting and boiling points. Lithium melts at 180.5 degrees Celsius, and iron melts at 1538 degrees Celsius. Note that there can be a big difference between the melting point of different metals. This is due to the different charge of the ions and their different radii. For more on this, check the IB A-level videos. Remember that ionic compounds also have high melting and boiling points. The high melting point of metals makes them useful in many everyday applications. For example, most pots and pans are made from metals. They can be heated without melting. Metals are malleable, which means they can change shape without breaking. If a pressure is applied to a metal, a layer of cations may shift, as shown in the diagram. However, the attraction between the cations and the delocalized electrons keeps the structure intact. Remember that when layers shift in ionic lattices, the repulsion causes the layers to break off. As a result, metals can be hammered into different shapes. Blacksmiths used to make swords by hammering a hot piece of metal. Metals are also ductile, which means they can be drawn out into a wire. Copper is often made into wires to be used in electrical devices. We will discuss this further in the next slide. Metals are good thermal and electrical conductors. Solids transfer heat by conduction. If one end of the material is heated, the atom vibrates more, causing the neighboring atom to also vibrate more. In metals, not only do the ions conduct heat by vibration, but so do the electrons by moving through the lattice, colliding with other electrons or ions. Metals are therefore better conductors than other solids. As the electrons are free to move throughout the structure, metals can also conduct electricity. Metals conduct when solid or when molten. This is in contrast to ionic compounds that conduct only when molten or dissolved. As discussed in the previous slide, copper wire is used in electrical devices to conduct electricity. In this animation, see the link in the description, we can see how heat is conducted in a solid. The blue circles represent the atoms at a lower temperature, and the red circles represent the atoms at a higher temperature, vibrating more. In this animation, see the link in the description, we can see how the electrons, the green circles, flow across the wire. The yellow and the red dots are the protons and the neutrons in the metal nuclei. In conclusion, the cations in a metal are arranged in a lattice, while the electrons are delocalized throughout the structure. Metals have high melting and boiling points and are malleable and ductile. Metals can conduct heat and electricity. Thank you for listening. Make sure you also watch the videos on covalent and ionic bonding in the bonding playlist. If you haven't already, please subscribe for more content. Stay curious.